What's up guys, Major Math with another video on fluid mechanics. If you have any questions, drop it in the comments, and if you're having trouble with other problems, I've attached my email in the description, so please feel free to reach out. Without further ado, let's get started. Question 3.97, the textbook says an irrigation ditch is full with slack. Velocity equals 0 meters per second. Water temperature is 5 degrees Celsius, restrained by a closed gate. The ditch and gate are both 2 meters wide by 1.5 meters deep. Find the force acting on the gate and the location of the center of pressure on the gate as measured from the bottom of the ditch. There is no water on the downstream side of the gate. So let's figure out our goal here. Our goal is to find the force acting on the gate, so due to pressure, so find pressure force and find the location of the center of pressure. Alright, so let's write our givens too. Okay, our givens, temperature is 5 degrees Celsius. So that means if we're using the textbook that the specific weight of water equals this. Velocity is 0 meters per second. We don't need to write that. The ditch and gate, the ditch where the water is and the gate are 2 meters by 1.5 meters. Okay, and then that's all we need. And then we're going to assume that they don't really give us a clear, but we're going to assume that this gate is completely upright, so 90 degrees. Okay, let's draw this ditch with the water and the gate. So it says 2 meters wide. So the wide, that's not gonna be this. That's gonna be into the page, right? So we're not gonna write that dimension, but we can write that this is 1.5 meters. Alright, and then that width is into the page. And then here's our water. So this is the gate, this big thing is the gate, and then this is our water. So we gotta find the pressure. So this water is putting pressure onto this gate, and we gotta find the amount of pressure, or the measurement. So the equation to find the pressure force is this. When we're dealing with pressure force, this line over just means with respect to the centroid. So the centroid in this case of the gate would be half, since it's a rectangle, it would just be half of 1.5 meters, so it would just be 0.75 meters. You can also rearrange this to pressure. We know that pressure can be is equivalent to the specific weight. In this case, it's water, the specific weight of water times the height with respect of the centroid times area. Put area of the gate. So we know if we use a textbook, we look at 5 degrees Celsius. I already wrote it. we know the specific weight of water. The height, we know, so we need to the water and the gate are at the same level. That looks terrible. Okay, so to find this height of the from the surface level of the water to the centroid of the gate, that is just that 0.75, right? That's the distance from the water level to the centroid of the gate. And then the area of the gate, it's a rectangle, so that is just length times a width, okay? So we'll write that here, or I guess in this case it would be the height times the width. So that's just 3 meters squared. So let's plug everything we know in. The height, yeah. And then the area is 3 meters cubed. Put that in your calculator. You get that the pressure force is 22,072.5 newtons, which is about equivalent to 22.1 kilonewtons. Okay, so we found the pressure acting on it. For the location of the center of pressure, right? So I'm gonna draw our gate again. So this is our same gate that we've been working with. We found the centroid, right? The centroid, since it's a rectangle, is just at that 0.5 meters, just half of 1.5. But then, if we think about water, we know as you get deeper within water, the higher the pressure gets, right? So that means that the pressure acting on this gate increases as you get to the bottom of the water. And textbook describes it like this. It's actually linear and it creates this triangle shape, right? So the amount of pressure is smaller up here acting on the gate, and then it gets bigger and bigger and bigger and creates this right triangle. So, and that only happens because this gate is completely upright. If the gate was curved or if the gate was at an angle, this would not apply. The part that would apply though is still that the farther down of the water you get, the more pressure it would have on the gate, but it wouldn't create this perfect right triangle of velocity or pressure force. That only occurs when the gate is completely upright. So using this knowledge to our advantage, we actually know that the location of the center of pressure, represented by this, so the centroid has got a little stuff filled in, the center of pressure doesn't have anything filled in. We know that this is actually 2/3 down, right? So since the gate is completely upright, we know that the 1.5 meters times 2/3 equals 1 meter. So we know that center of pressure is going to be 1 meter down from the surface of the water, or you could say that the center of pressure is half a meter from the bottom. So that's the location of the center of pressure. Thanks for watching, soldiers! Don't forget to leave a like and subscribe for more content like this. If you have any questions, leave it on the comments, and if you need help with any other problems, feel free to contact me with the email shown on the screen.